Good morning, everyone. Today, I, Prasanna Kumar from CSMC, will be presenting on the topic stack of plates. In computer science, a stack of plates is a simple word and powerful analogy to explain how a stack data structure works. Just like in a real stack of plates, the last plate placed on a stack is first one you take out. This principle is known as LIFO, last in, first out, and understanding it is crucial for solving various problems in computing. What is stack data structure? A stack is an abstract data type that manages a collection of elements with specific operations. It supports two primary operations, push and pop. Push means add an element, pop means remove the top element. Stack are used in many algorithms such as expression evaluation, backtracking, and function call management. A stack is an abstract data type used to store and manage a group of elements. It mainly supports two operations, push adding an element to the top, pop removing the top element. Stack are used in algorithms related to expression evaluation, backtracking, recursion, and many more. It is one of the simplest but most important data structure in computer science. Real world examples of stacks. A stack of plates at a buffet is a physical example of a stack data structure. Undo mechanisms in text editors utilize stacks to revert actions. Browser history navigation uses a stack to keep track of visited pages. We see stacks around us every day. A stack of plates is a most common example. Other examples include undo actions in text editors. Every change is stored in a stack. Browser history. Your visited pages are stored in the order you visited them. Whenever you go back, the most recent page is removed first. These real world examples make the concept very easy to understand. Basic operations of stack. Push adds an element to the top of the stack. Pop removes and returns the top element of the stack. Peek or top allows viewing the top element without removing it. Stack support three main operations, which are push adds an new element to the top, pop removes the element from the top, peek which helps us to view the top element without removing it. These operations maintain the LIFO structure. Stacks also support checking if the stack is empty or full in some implementations. Advantages in using stacks. Stacks provide a simple way to manage data with a clear order of operations. They enable efficient implementations of algorithms like depth first search. Stacks help in managing functions like calls and recursion in programming. Stacks offer several advantages. They provide a simple way to manage data in a defined order. They support efficient algorithms such as depth first search, that is DFS. They are essential in function call management, recursion, and memory management. This structured way of organizing data makes stacks very powerful for problem solving. Limitations of stacks. Stacks have limited access, only allowing operations in the top element. They can lead to the issues like overflow if the stack exceeds its maximum size. Improper management can cause stack underflow when attempting to pop from an empty stack. However, stacks also come with limitations. You can only access the top element, everything else is hidden. A stack can overflow if it reaches maximum size. A stack underflow occurs if we try to pop from an empty stack. Because of these limitations, programmers must use stacks carefully. Stack implementation methods. Stacks can be implemented using arrays or linked lists. Array-based stacks are simple but have a fixed size. List-based stacks are dynamic and can grow as needed. Implementing a stack in Python. Use a list to represent the stack in Python. The append method corresponds to push. The pop methods removes the last element representing pop. Implementing a stack in Python. In Python, we typically use a list to create a stack. The operations are simple. Append is used for push, pop is used for pop. This makes stack implementation straightforward for beginners and useful for many problems. Implementing a stack in Python. Another way is using linked list. We create a node class with data and a reference to the next node. A pointer keeps track of the last inserted element. Push and pop operations only change the top pointer. This method avoids the limitations of fixed size structure. Problem solving with stacks basic example. One simple example of stack-based problem solving is reversing a string. We push each character onto the stack and then pop them one by one. The result is the reverse string. This shows how the natural LIFO behavior helps solve real problems. Common algorithms using stacks. Stacks are used in many important algorithms. Depth first search, that is DFS, expression evaluation, infix, postfix, prefix. Balancing symbols like parentheses, braces, and square brackets. Without stacks, these algorithms would be harder to write and understand. Solving complex problems with stacks. When solving complex problems, stacks help in managing nested structures, parsing expressions in compilers, syntax checking in programming languages, managing nested HTML or XML stacks. Stacks provide a simple and efficient way to handle these deeply nested structures. Tips for effective tips for effective problem solving with stacks. Here are some tips when using stacks. First, identify if the problem requires LIFO behavior. Use auxiliary stacks if one stack is not enough. Always check edge cases like empty stack before popping. These tips help avoid common mistakes. Common mistakes to avoid. Some common mistakes include forgetting to check for underflow before a pop operation, ignoring maximum size limits in array-based stacks, confusing stacks with queues which use FIFO instead of LIFO. Before aware of Being aware of these mistakes makes your code more efficient and error-free. Practice problems to develop skills. Implement a function to check for balanced parentheses. Create a program to convert infix expression to postfix notation. Design a stack-based algorithm to evaluate postfix expressions. To strengthen your understanding of stacks, you can try checking for balanced parentheses, converting infix expressions to postfix, evaluating postfix expressions using stacks. These are some of the best problems to master stack operations. Real world applications of stacks. Syntax parsing in compilers and interpreters, backtracking algorithms in puzzles and games, managing undo operations and navigation history. Stacks are used in many real world applications. Compilers use stacks for syntax parsing, backtracking algorithms for puzzles like mazes or Sudoku, undo functionality, browser navigation, and game development. Understanding stacks helps in understanding how many real systems work. Stacks are fundamental in managing ordered hierarchical data. They simplify complex problems by providing clear operation rules. Mastery of stacks enhances overall problem solving efficiency. To summarize, stacks help manage hierarchical and ordered data. They simplify complex problems. They are essential in algorithms, compilers, and memory management. Knowing how and when to use a stack strengthens your problem solving skills. Remember the LIFO principle as the core concept of stacks. Practice implementing stacks in different programming languages. Recognize scenarios where stacks provide optimal solutions. The most important points to remember are LIFO is hard stack operations. Practice stack implementation in different languages. Identify problems where stack based solutions are optimal. Once you master this, many programming problems become easier. Breakdown Final tips for problem solving. Break down problems into identify where stack operations fit best. Use visualization to understand how the stack behaves during solutions. Continuously practice with real world and theoretical problems. When solving problems, break the problem and find where stack operations fit. Visualize the push and pop sequence. Practice regularly with real problems. These habits will help you become better at data structures. Understanding stacks is crucial for mastering data structures and algorithms. Keep practicing problem solving techniques involving stack regularly. Explore advanced topics like stack based algorithms and applications further. In conclusion, understanding stacks is essential for mastering data structures and algorithms. It is a simple concept but extremely powerful in problem solving. With continuous practice, you will be able to apply stacks efficiently into many real world challenges. Thank you for listening. Thank you.